Pneumatic cylinder is a linear actuator powered by compressed air to supply force on a load. The assembly shown here is the most common type of double-acting pneumatic actuator used in industries. It consists of a piston rod. This rod transfers force of compressed air to the load. Cushioning pistons are assembled with this rod. These pistons prevent any hard shocks at the end of the stroke by enabling the piston to stop slowly and gradually. The piston reciprocates back and forth when there is pressure difference between any of the two sides. A static seal ensures airtight sealing between the piston and rod. Piston guide rings are assembled to prevent metal-to-metal contact of piston and cylinder. Piston seal provides airtight sealing between the cylinder and piston. This whole assembly then goes into a cylindrical bore. This cylinder is generally made up of aluminium or steel. A cylinder cap encloses cylinder chamber in one end and the cylinder head encloses a chamber from the other end. Cushioning buffers and seals are installed on respective ends. Captive adjustable cushioning screws are installed on each end. These screws enable user to adjust the optimum cushioning at the end of the stroke. This whole assembly is held together with tie rods. These rods also provide compressive and tensile strength to the actuator. Air ports are screwed to the ends through which compressed gas flows in and out. A pneumatic valve is connected to these air ports using pneumatic hoses. The valve shown here is a 5-port 4-way valve. The ports A and B are connected to the cylinder. Port P is connected to the compressed air supply unit. Ports R and S are exhaust ports to which the pneumatic mufflers are attached. Now let's understand how a pneumatic cylinder works. The compressed air is supplied through inlet port P of the valve. The valve directs air to a particular direction, which we can observe in the animation. In this case, the air is directed to port A. This high-pressure gas is then transferred to the cap end of cylinder through the pneumatic hose. This creates high pressure in the cap end of cylinder, which therefore pushes the piston towards the head end. This also pushes gas from the head end. This exhaust gas travels through the other hose and reaches the valve. The valve directs this gas towards port S and allows it to escape through a pneumatic muffler. The gas muffler helps to reduce any noise produced during exhaust. The process we just observed is the extension stroke of actuator. During the retraction stroke, the valve directs compressed air to the head end of cylinder. This causes the piston to return and air on the other chamber escapes from the exhaust port R. The theoretical force of actuator is the relative pressure on the piston multiplied by effective area of piston on which pressure is exerted. Here, the relative pressure is pressure of supplied air minus the atmospheric pressure. During extension stroke, compressed air can exert pressure on total cross-sectional area of piston. This gives us the expression of theoretical force as relative pressure multiplied by total area of piston. During retraction, the effective area of piston is reduced because the air cannot exert pressure on the area of rod. This gives us the expression of theoretical force as relative pressure multiplied by partial area of piston.
That means that it has mounting threads both at the tail and the head of the cylinder. There are many different varieties of cylinders, but this one is the most common, and it's what we're going to be using for our demonstration today. This one is an 1/8 inch NPT solenoid. That means that these female threaded holes are 1/8 inch NPT. We have several fittings, the correct size to match. You'll see that these fittings are threaded on one end, and the other end has a plastic ring to accept 1/4 inch outer diameter airline. Alright, so those fittings are installed. That's how we're going to get air into and out of the solenoid. Now we need to be able to get air into the cylinder. For that, we have these elbow fittings. These fittings are similar to the ones we just used. They have a threaded end here, they turn at 90 degrees, and then they have the plastic ring for inserting your airline, 1/4 inch again. So we have 1/4 inch airline here, 1/4 inch airline here. Alright, now we have our elbows installed into our cylinder. We have our fittings installed into our solenoid. The last thing that we need to do for our solenoid is install some mufflers into the exhaust ports. For the exhaust ports of the solenoid, we have these 2 breather vents. You can see that these fittings are threaded on one side, and they have a muffler on the other. The primary purpose of these is to block debris from entering into the exhaust ports of the cylinder, but they also help to slightly muffle the sound of the exhaust. For this, we're going to be using some 1/4 inch polyethylene airline. This is the most common type of airline used in this sort of application. So we have these 2 pieces like that. We're going to take one of the pieces, insert it into the first of the 2 fittings. You just press it in firmly until you feel it slightly depress into the fitting. You should be able to tug on it and not be able to pull it out. And port A we're going to be putting into the top port of our cylinder. Alright, now we're going to go ahead and take the second piece of air line, plug that into the fitting that's coming out of port B, and plug that into the bottom port of our cylinder. Input of the solenoid. Now the last thing we want to do before we connect air to our solenoid is check our air pressure. Your compressor may have a regulator like this one. Turning the dial at the top of the regulator will adjust the air pressure. Somewhere around 40 to 50 psi will be fine for most pneumatics. We can now test our solenoid to make sure it's operating properly. You can see that there's a small silver button here on the edge of the solenoid. We can go ahead and depress that and it will actuate our cylinder. Alright, that's working fine. The next step is to control this setup. As I said before, the solenoid is essentially an electric switch, so we need something that can tell this when to turn off and on. For that, we're going to be using a Peekaboo 1 controller. With this controller, all programming is done on the controller. You're just going to hit record, tap out a sequence, and hit record again to save. Let's do that now.